Example number 1. What is the total number of orbitals associated with principal quantum number n is equal to 4? When the principal quantum number is equal to 4, how many orbitals are possible? Now, there are three ways in which you can solve. The first way is, if you consider n is equal to 4, the first method I'm talking about, when n is equal to 4, n is equal to 4, L is equal to 0, 1, 2 and 3. So these are the L values. If L is equal to 0 means it is S subtion, it is P, D and F. Now if you consider S, there is only one orbital. If you consider P, you have 3 orbital, D you have 5, and if you consider F, there are 7. So totally count it, it's 10 plus 5 plus 1. So totally you have 16 orbital. This is one way. So this is method number 1. Then what's the second method? Second method is n is equal to 4 means total number of electrons in that shell. Total number of electron in that shell will be 2n square. So it is 2 into n is 4 square. So 4 square means it is 16. 16 2s are 32 electron. We know that in each orbital there are 2 electrons can be accommodated maximum. If I want to accommodate 32 electron, half of the orbital, that is 16 should be there. 32 electron means to accommodate 32 electrons, we should have 6 electrons. Then the third method is n is equal to 4 means L is equal to 0, 1, 2 and 3. We know that the number of orbitals is equal to number of orbitals for a given L value is equal to 2L plus 1. This is the formula we have. When L is equal to 0, so total number of orbitals will be 1. If L is equal to 1 means it's 2 into 1 plus 1, that's 3. L is equal to 2 means it's 4 plus 1, 5. So L is equal to 3 means it's 2 3s are 6, 6 plus 1, 7. So totally how much did you get? 16 you get. 16 orbitals. So these are the three ways in which you can solve it.